Hello class, this is Miss Morris. Today we're going to take some notes on classifying triangles. I know that you guys did a small lesson on Delta Math, which that will be your assignment for tonight. But let's go ahead and take some notes over this. First thing I would like to point out is the way we talk about triangles. So we have a symbol for it, and it's the triangle up here at the top. So if we want to talk about a specific triangle, we use the triangle symbol. And then the three vertices, so the three corners of the triangle. So that's the first thing we want to talk about. Second thing, so this is split up into two different categories. We can classify triangles by their angles or by their sides or by both. So let's go ahead and fill out these notes. So first, let's look at how we classify them by their angles. The triangle here first, triangle ABC, is an acute triangle because all angles are less than 90 degrees. Let's go ahead to the next one. The triangle to the right is a right triangle because one of the angles is 90 degrees. That would be angle B. And please note here to prove, right now it might not make sense, but later on in your the rest of the notes and the examples, you will need to use that. So it says to prove, use the slope formula and show that two sides are perpendicular. So remember, if two sides are perpendicular, you're supposed to think 90-degree angles. So that means that that side AB and BC are perpendicular to each other because they form a 90-degree angle. Okay, next. This triangle is an obtuse triangle because one of the angles is greater than 90 degrees. So that the angle that's greater than 90 degrees is angle C. So those are the three ways that we can classify triangles by their angles. Now let's look at the three ways we can classify by their side lengths. So on the triangle to the right, you'll notice that each side length is different. I know that because this has one tally mark, this side length has two, and this one has three. So we call this a scalene triangle, where all sides are different lengths. To prove that, you're going to use the distance formula to show that all side lengths are different. Moving on to the next one. Next one is an isosceles triangle. It's where two side lengths and two angles are equal. So notice that there's one tally mark here and one here. That means those two sides are equal. And then these angles are congruent. So it has two angles congruent, two sides congruent. And to prove this, you're going to use the distance formula to show that only two sides are congruent. And last but not least, we have an equilateral triangle, which means that all sides are equal and all angles are equal. Also, in an equilateral triangle, the angles will always be 60 degrees. I think that's the only way it could work out. Let's go ahead and move on. So some important formulas that you're going to need for this lesson. You're going to need to remember the slope formula. So that is y2 minus y1 over x2 minus x1. That is our slope formula. And then our distance formula. So distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So we'll use both of these formulas in this lesson. So just good things to remember. Next, let's go ahead and look at some examples. So part A of number 1 says classify triangle PQR. So triangle PQR, let's first see where that is. So PQR is this triangle right here, and it says classify it by its angles. So we just need to determine, is this acute, right, or obtuse? Which, if we look here, angle Q is an obtuse angle. It's greater than 90 degrees. So therefore, our answer for here is obtuse. Okay. Let's go ahead and look at the next one. So the next one says classify triangle PQS. So PQS is this triangle right here. And it says classify it by its sides. Well, there's no markings on its sides. There's no measurements. So the thing that you need to look at here is these two angles right here. They're both 45 degrees. So that means that two angles are congruent, which means the two sides are going to be congruent. So sides QS and PS are congruent, therefore making this an isosceles triangle. Okay. Let's go ahead and move on to the next. So I'm going to kind of get you started, and then I would like you to finish, and we can check notes on Tuesday. So it says triangle AFN has vertices at those 3 points. Prove that triangle AFN is an isosceles triangle. I gave you a hint that you need to use the distance formula. So if you go back up here, we're going to look at isosceles, and it says to prove, we need to use the distance formula and show that only two sides are congruent. So you must use the distance formula 3 times to show that two sides are congruent, and then the third side is not congruent. Okay, so let's go ahead and plot this. It's going to be -7, 6. That's A. And then -1, 6. That's F. And then -4, 2. Okay, so this is A, F, and N. And lucky for us, AF, we do not need to use the distance formula because it is a horizontal line. We could just count it. 1, 2, 3, 4, 5, 6. So we'll just say that that is 6. Now, we do need to find the distance between AN and FN. So you will use the distance formula and prove whether or not it's an isosceles triangle. Okay? Next, let's move on. Okay, next it says prove that A, B, C are vertices of a right triangle. Use the slope formula. Again, you're going to want to plot the points. I think I messed up on that last point. Whoops. There we go. So this is A, B, and C. We're going to go ahead and draw it. To me, it looks like angle B is possibly the right angle. So we need to see if sides AB are perpendicular to BC. So I need to know the slope of AB, and I need to know the slope of BC. So you are going to find the slope of AB and the slope of BC. If they're perpendicular, that means that they'll be opposite reciprocals, and they do form a 90-degree angle. So I'm going to have you guys go ahead and do the work there. Like I said, we will check on on Tuesday. And last but not least, sometimes we're not going to be given a graph, and it might just say, find the measure of the sides of the triangle and classify it by its sides. So we need to know if it's scalene, isosceles, or equilateral. We need to find the distance or the length of each side by using the distance formula. So in this first bracket, I would probably do points X and Y, find the distance there. And in the next one, find the distance between Y and Z. And then last but not least, the distance between X and Z. Okay, if all three of them are equal, it's an equilateral. If all three of them are different, it's a scalene. If two of them are the same, then it's an isosceles. Again, we will check answers on Tuesday. After you've completed your notes, go ahead and get on to Delta Math. There's going to be a couple extra distance problems there just to practice the distance and the slope formula. Have a great day.